Hello, I'm Dr. Momina. I'm an academic cardiology registrar in London and a research fellow at the Royal Brompton Hospital, working with Professor Sanjay Prasad. My research project is focused on myocarditis. Specifically, I want to understand what genetic properties patients possess which may make them more prone to the disease and which may mean they're more vulnerable to some of the poor outcomes we see in myocarditis, such as sudden cardiac death and heart failure. And this is an area that's very poorly understood. My research has brought me here to Hamburg in Germany. I've been here for the last month in the laboratory of Professor Thomas Eschenhagen. He is an internationally renowned scientist and a global expert in a technique called induced pluripotent stem cell technology and engineered cardiac tissue engineering. So as previously mentioned, we know that patients with certain genetic variations may be more at risk of contracting myocarditis. And the genes in particular that I'm interested in are titin and desmoplakin, which are proteins in the heart, and something that we've observed from our research at the Brompton. What we don't really understand yet is why these genetic variations make patients more vulnerable, and whether these variations do lead to worse outcomes in the future. So I'm hoping to study this using cardiac tissue in the lab. And so I just wanted to show you what I've been doing so far. These are stem cells that I've been growing. They originated from a patient who has a titin genetic variation. They originally started life as a skin biopsy. Professor Eschenhagen has turned them back into stem cells, and then while I've been in Germany, I've been expanding these stem cells. So now here we have some stem cells that I've been growing that have a desmoplakin genetic variant, and these are slightly more mature, and I've added a series of growth factors to these cells. So they differ from the last plate in that they are more confluent and more densely packed. And so hopefully these are now at the stage where they're ready to turn into cardiac tissue. So one of the main reasons I wanted to come to Germany to learn from Professor Eschenhagen is a technique called engineered heart tissue. This is where we take the stem cells that I showed you before and turn them into cardiac tissue. And here is some engineered heart tissue that I have learned how to cast here. So they are in little moulds held up by racks. There's about 1 million cardiac cells per tissue, and they spontaneously beat, just like we see in the heart. So this is extremely cool, and it allows us to study heart disease in the laboratory. I want to harness this technique in myocarditis. And so the aim of my project is, now that I've learnt these skills here in Germany, is to take them back to London and the Brompton. I will have the stem cells with the desmoplakin and titin genetic variants, and I will cast engineered heart tissue just like this. And really the crux of the project is to then expose those engineered heart tissue to myocarditis conditions, so to expose them to a viral illness, and then study their properties. These properties would include the pumping strength of the tissue, the electrical conductance of the tissue, to help us understand how these genetic variants may make patients more at risk of arrhythmias and sudden cardiac death, and then finally the ability of the tissue to defend itself against viral illness, as we know that viruses are the most common trigger of myocarditis. So to summarise, the aims of my project are to study in a very detailed and specific way how these genetic variants may make patients more prone to developing myocarditis. The short-term impact of this work could be that genetic screening and counselling could be incorporated into clinical practice for patients and families. And the long-term alternate aim of this work is to begin to understand some of the specific pathways that may be relevant in myocarditis that could be targeted for more directed treatments. It's been a privilege and an amazing opportunity to visit Professor Eschenhagen's lab in Hamburg. I've learned so much about induced pluripotent stem cell technologies and engineered cardiac tissue. These are really cutting-edge and innovative scientific techniques, to the extent where induced pluripotent stem cell technologies actually won the Nobel Prize for Medicine in 2012. My aim is to harness these skills and transfer them back to London to study myocarditis for the benefits of patients and their families.